In this next video, in section 11.1, we're going to start talking about the trigonometric ratios. Now on the worksheet there you can see the definition of the ratios we'll be considering. And the big idea with trigonometric ratios is to relate the sides of a right triangle, so say side A, B, and C, to an angle of the triangle. And here I've labeled this angle theta. That's a Greek letter commonly used to denote angles. Okay, so the first ratio we're looking at here is the sine ratio, abbreviated SIN, of theta. And by definition, this is the length of the opposite side of theta divided by the length of the hypotenuse. Okay, so in this figure, I've labeled the side opposite theta just op, and the hypotenuse is the long leg, the longest leg of the right triangle. And another way to say that is it's the side opposite the 90-degree angle. Okay, so here this is going to be the ratio of A, that's opposite theta, divided by the hypotenuse, which is C. Okay, next up we have the cosine ratio, cosine of theta. This is defined to be the length of the adjacent side of theta, so that's this length right here, the length next to or adjacent to the angle, divided by that hypotenuse length. So in this figure, that would be the ratio of B to C. And then lastly, we have the tangent of the angle. This is written tan theta, and this is defined to be the length of the opposite side divided by the adjacent side. So that would be opposite side A divided by the adjacent side B. Okay. Now, useful mnemonic here, just to help you remember these definitions, is what's called Sohcahtoa. Okay, and what this is saying, just going back up to our definitions, so starting with sine, well, this is sine is the opposite divided by the hypotenuse. Okay, so is S-O-H, right? There's so. Then on to ca, that's cosine is the adjacent divided by the hypotenuse. Okay, so this is CAH, and then lastly tangent, and that would be T. Tangent is the opposite divided by the adjacent, and that is the TOA portion. Okay, so before we look at an example, I'm also just going to mention that we can relate the three sides of a right triangle through the familiar Pythagorean theorem. This will be useful from time to time in some of the problems we'll look at. And here that would say that the sum of the squares of the two legs of the triangle, so these are the non-hypotenuse legs, so this would be a squared plus b squared, that is going to come out to be the same thing as the square of that hypotenuse length, so that would be c squared. Alright, great. So now let's go ahead and look at an example. So I brought up here an example where the given angle is 60 degrees, the hypotenuse leg is, the hypotenuse length is 2, and the adjacent side there is 1. Now if I want to go ahead and find the side length A, we'll first note that this is the side opposite the angle of 60 degrees. Okay, so one way I could set this up is to relate, say, the opposite side A to the hypotenuse, which is 2. So opposite hypotenuse, that would be the sine ratio. So I can say the sine of 60 degrees is equal to the ratio of A divided by 2, right? Opposite divided by hypotenuse. Alright, great. So I'm going to go ahead and solve this now for A by just multiplying both sides of the equation by 2. And this is going to give me A on its own here. And so here I'm getting that A is equal to 2 times the sine of 60 degrees. Okay. Now I'm going to go ahead and use a calculator to approximate this. And to do that, I'm going to go ahead and bring up I already get rid of that for now. A online graphing calculator. This is can be found at desmos.com. I highly recommend you check this out. Now, if you have your own calculator, say a TI or a basic scientific calculator, those are going to be more than sufficient for the class. But when we get into graphing in particular, this calculator is really impressive, and I'll be using it quite a bit throughout the quarter, so I encourage you to check this out. Okay, so one other thing before I do this calculation, go into the settings in your calculator. So when you're working with angles, you want to make sure you're in the right mode. So here for Desmos, the settings can be found in the upper right hand corner, this little wrench button. So I click on that, and notice at the very bottom here there's it says radians and degrees, these two little buttons. So radians are another way to measure angles, okay, as opposed to degrees. We're not going to get into those in this class. We're going to stick with degrees, and so I'm going to make sure that this is in degree mode. Now, again, if you're using another calculator, be sure that your calculator is in degree mode. If you have any questions about how to get that to work, please don't hesitate to reach out. Okay, so coming back now, I'm going to go ahead and punch in. This is 2 times the sine of 60. And I'm getting about 1.732. Okay, so I'll go ahead and record that here. So 1.732. All right, so this right here is that missing side. Okay, now one way I could go ahead and check this answer is through the Pythagorean theorem. Okay, so to check, I could say, well, if I've done everything correctly, right, then I know that the sum of the squares of these two legs has to come out to be the square of this hypotenuse. Okay, so is that true here? Well, is 1 squared plus 1.732 squared the same thing as the square of the hypotenuse? So 2 squared. Well, let's go back to the calculator and check it out. So I'm going to do here 1 squared, which is of course just 1, plus 1.732 squared. Notice I don't get exactly 4, right, which is what I have on the right side, 2 squared. I get 3.99824. So I'm going to go ahead and record that here. And so, whoop, not that. Here we go. Back to action. 3.99984. So did I do something wrong here, right? Given that the right side is exactly 4. Well, the answer there is no. I'm okay here. Remember, I rounded the value of a up above, right? So the fact that this is really close to 4, but not exactly 4, is in fact to be expected, okay? So we're all good there, all right? And now the last thing I want to say here, a slightly different way to approach the solution for A, and I'm not going to go through all the details, but I just want to point this out. Now here, I related A, the opposite side, to the hypotenuse, and I did that with the sine ratio. I could just as well say related the opposite side A to the adjacent side of 1, okay? Now, opposite and adjacent, that would be referencing the tangent ratio. So I could also set this up as tangent of 60 degrees is equal to opposite over adjacent, so this would be A divided by 1, and now notice A divided by 1 is just A itself. So if you go ahead and use your calculator and punch in the tangent of 60 degrees, you will find again that our value of A is 1.732. Okay, so go ahead and check that. That's going to do it for this problem.